Hi everyone, welcome to Chem 331. This is going to be our second laboratory for the term, and today we will be extracting and separating acid, base and neutral compounds from each other. Okay, so this lab requires a lot of finesse and absolutely no rushing anywhere, because this is one of those labs that's not difficult, but it's not easy to maneuver either. Okay, so take one step at a time. Okay, and if you have any doubts at any point before you do it, ask me. If you make a mistake in any one of these steps, then the chances are you can't just fix it. You have to start over from the beginning. If you make a mistake in step 8, we can't just fix step 8. You have to start over from step 1 all over again. Okay, I have tried things differently this time. I actually took photographs at each stage of the experiment, and then I've compiled a presentation video of the visuals. If you like this method, I would be happy to do it again for the reminder videos, because it's easy for me since I'm alone in the lab doing this. It's really difficult for me to video while I'm doing the experiment without losing concentration. And I think this literally walks you through picture by picture how each thing looked at each phase of the experiment as I did it. Alright, so two things. Safety. Some of these chemicals are totally not forgiving. Alright, there's little you can do if an accident happens. Alright, so please have your goggles, lab coats and gloves at all times, no exceptions. If you have to take a break, you can take off your goggles and gloves. As soon as you get back in the lab, you gotta have them on. As I said, I cannot emphasize safety. These chemicals are not forgiving, so if something happens, we can't just go back and fix it, just like how we can't fix any of the mistakes in your steps as you do the lab. So keep that in mind. Safety, number one priority. Number two, this lab requires finesse. You just can't mess up any of the steps. If you do, you have to start over from step 1. So you're step 20 and you mess up step 20, you just can't go and fix what you have done. You have to start over from step 1. Okay, and I have precisely made chemicals for this lab so we don't generate a lot of waste. So you do it right once, but do it right. You're going to finish this lab with no problems. I'm not saying you'll finish faster, but I'm saying you'll finish with no problems. There's absolutely no issues as far as the lab itself, but you have to do the steps correctly. So I'm going to walk you through every step and how things look like at each phase. So please pay attention, and I will provide a copy of this PowerPoint as well. This is not the written procedure. You still have to follow the picture for what it is. All right, so let's get started. So I would have already mixed the chemicals in a mixture. From the mixture, you would weigh approximately 3 grams. Okay, approximately 3 grams. Don't go too much past 3 grams because it's just going to take a lot longer. And once you weigh the 3 grams, transfer that mixture into a 100 milliliter beaker provided. You would be provided with 4 or 500 milliliter beakers, so label, just pick one and transfer the 3 grams that you just weighed into a 100 milliliter beaker. All right, then using one of your, I will provide at least 3 measuring cylinders. Grab one of them, add about 10 milliliter of DCM, okay, into the measuring cylinder. DCM is dichloromethane or methylene chloride. I will provide this for you because this is a volatile compound and it is not very friendly. So I will provide this for you. So bring your measuring cylinder and get 10 milliliters of DCM. Once you measure 10 milliliters into a measuring cylinder, pour it into the beaker, and then using the glass rod provided, continuously stir or swirl with your hand. Make sure you don't spill anything anywhere. The more DCM you lose, you're going to have problem. You have to dissolve. Everything will dissolve. You can see there is no magic, it's science. Everything would dissolve, and the dissolved mixture is shown on the picture. You should not have any chemical or particles left undissolved. You have to make sure this step is done. Every step you're going to do it once and do it right, okay, because like I said, there's no coming back. You have to start over. So with that said, make sure you stir thoroughly until every little particle is dissolved. Everything will dissolve. I have done this lab and that's proof in front of you. Everything is dissolved. All right, so once you have the dissolved mixture, set that aside for a few seconds and make sure I will provide each of your station with a separatory funnel. That's what a separatory funnel looks like. And I would also provide a stand, a O-ring, and a triangle. Okay, you should have these 4 in your station. If you don't, tell me right away, because this is the setup that you're going to use to do the whole lab. All right, so you would need a separatory funnel, a O-ring, and a triangle, and an iron stand. All right, go ahead and set it up the way I have set it up here. All right, if you have trouble getting the flask into the triangle, stretch it a little bit. It's made of a flexible material, so it can stretch. Don't stretch it too much, okay? Just stretch a little bit so the whole thing can go in it. And make sure your flask, actually your separatory funnel, has a stopcock, the one you see in red, okay? I mean, all this would be already set up in your station. You just have to put them together. All right, and then now carefully transfer the dissolved mixture into the separatory funnel. Just pop the lid open on the separatory funnel, pour the entire mixture into the separatory funnel. Don't add anything else. All right, just what's in the beaker has to go into the separatory funnel, and you can see I have transferred it and it's now in the separatory funnel. Make sure the stopcock is in a closed position. If it's horizontal, means it's parallel to the table, it's closed. If it's vertical, it's open. So this is something you have to pay attention throughout. Every time we will take this out of the position, shake it, put it back. We will do this multiple times. Every time when there is substance in it, the stopcock must be closed. The only time we open it is to drain. So make sure the stopcock is closed before you pour the dissolved mixture in it. All right, so that's step 5. Everybody should be able to get through this pretty quickly, absolutely no problems. All right, now make sure the stopcock is closed, and then add 5 milliliters of 3 molar hydrochloric acid. I would provide all the reagents. You just have to come get your measuring cylinder. I'll pour 5 milliliters of hydrochloric acid into your measuring cylinder. Take that to your station and place the funnel back in the ring and allow. Okay, now add the 3 molar hydrochloric acid, the 5 milliliters, all of it into the separatory funnel. Okay, put the funnel lid back on. Okay, and then shake it thoroughly. I will show the entire class how to shake properly. Okay, you have to shake and vent, shake and vent. If you don't vent, there's going to be a pressure buildup and the glass will break. Of course, we're not doing any gaseous mixture, but still we have volatile compounds that would create a partial vapor pressure inside the funnel. So you have to shake and vent. I will show you all of you how that's done. If you're not sure, ask me. Okay, shake it a few times, give it a good shake, vent, shake. Usually I do it 4 to 5 times, shake, vent, in a matter of every few seconds. You don't need to shake it for half an hour, just shake it, and then put it back into the position and then allow the 2 layers to separate. Give it about good 5 minutes. Okay, now please don't take off your goggles while this is waiting. Okay, you are still in a lab environment, so goggles stay on. All right, so place the funnel back in the ring and allow the 2 layers to separate. Do not rush, give it good 5 minutes. If you let it rest for 5 minutes, you will see 2 layers. Clearly you will see 2 layers. One is the layer 1 on top, which is the aqueous layer, and then there's the organic layer. You will see 2 layers. You can see it clearly. I've marked them, right? Now, okay, let's go to the next step. While you're waiting for the 5 minutes for the layers to separate, take the remainder 3 beakers, label using the tape provided. Label one beaker as A, the other as B, and the other as N. All right, while you're waiting, so you save time. All right, now after 5 minutes, right, remove the funnel lid and then carefully open the stopcock so as to drain only the bottom layer into the beaker labeled N. Okay, make sure none of the top layer goes into that beaker labeled N, just drain only the bottom layer. Alright, you got to be very careful here not to drain any of the top layer, because that's just going to make things more difficult for you. It might lead to incorrect results. So try your best not to get any of the top layer into that beaker label N. Once you really get almost to the edge of the top layer, stop it. Now drain the top layer into a beaker label A. Alright? Okay. Now set the beaker label A aside. Take whatever you collected in the beaker label N, pour it back into the funnel, and then again come and get 5 milliliters of 3 molar hydrochloric acid from me. Take it back to your station, pour it back into the funnel, put the lid back on, shake when, and then put it back into the ring and then allow it to rest for 5 minutes. Okay, you will create 2 more layers again, the aqueous and organic. If you've got rid of all the aqueous in the first itself, you may not even have anything. You may have only one layer, which is the bottom layer, and then label that into the beaker labeled N. The bottom goes in the N beaker, and then if there is any top layer, that top layer goes into the beaker label A. All right, you see, after doing that step twice, I have 2 beakers, one with A, one with N. Okay, you can see the N looks a little cloudy because it's got the DCM in it. The A should be clear. Okay, A should be very clear. The N could be a little crowded. All right, cloudy. This is what it looks after step 11 when you've separated the 2. Moving on. Now transfer the mixture that's in the beaker N back into the separatory funnel. Okay, the funnel should always be in that position. It cannot be resting on your table, okay, because the lid is not secure. It will pop open and you will spill all your sample. Anytime you're not using the funnel, means you're not shaking, it's got to be back in its rest position. The stopcock is closed. So transfer the mixture from step 11 and then the beaker containing N back into the funnel, and then come and get 5 milliliter of 3 molar sodium hydroxide from me using the 3rd measuring cylinder. Take it back to your station, pour it into the funnel, shake when, allow it to rest for 5 minutes. Okay, at step 15 you would see 2 more layers separated. The top layer is aqueous, the bottom layer is organic. Just like you did previously, drain the organic layer into the beaker labeled N. You would be using the same beaker multiple times. Don't worry, it's not contaminating anything. You're going to drain the bottom layer into the beaker named N, the top layer into the beaker labeled B for base. Okay, careful not to mix 2 layers in the beakers. And now again, get 5 molar sodium hydroxide from me, 5 milliliters of 3 molar hydrochloric acid from me. Shake with frequent venting, allow the layers to separate as in step 7. Okay, and then after 5 minutes, remove the funnel lid, drain the bottom layer, organic layer, into the beaker labeled N, and then the top layer into the beaker labeled B. If at all there is any. Normally you would not have much at all after the first run, but you have to do it twice just to make sure there is no base or acid left in the top layer. All right, now when you are finished at step 18, at the end of step 18, you will have 3 separate beakers each. I'm using conical flasks here, but I can provide you these conical flasks. They're not meant for this, but you'll be provided with beakers. You'll have 3 separate mixtures. This is where the first part of the experiment ends. If you are not here, then you have a problem. Okay, you would see that the A looks clear and N and B would be slightly cloudy. Okay. All right, moving on. You would be able to finish most of this today in lab. There's only one thing that you will not be able to do. I'll tell you what it is. Now, take the beaker containing the solution N, which is for neutral, bring it to me. I will add sodium sulfate to it. Okay, give it a good swirl and then cover it with a paraffin film, set it aside. Okay, don't do anything to it now. I will add the sodium sulfate into your beaker labeled N. Give it a good swirl, put a paraffin film, set it aside. All right, moving on to step 20. Again, come and get a small amount of 6 molar HCl from me. I will provide that to you. Using a pasture pipette, I'll provide those plastic pipettes. Carefully add the drop at a time or few drops at a time with constant swirling. You will see the white precipitate will appear and disappear, appear and disappear. You've got to add until the precipitate is stable, and you can see the precipitate is stable. That's when you stop step 20. You don't need a lot, but you don't need one drop, you need few drops, but you have to add and swirl until the precipitate does not disappear. That's B. Step 21, same deal. You have to come bring the measuring cylinder and get sodium hydroxide this time. Using a different pasture pipette, start adding few drops at a time until the precipitate does not dissolve and does not disappear. All right, that's step 21. Now you see we are now starting to get our compounds back from the mixture. All right, step 23. Okay, carefully siphon out or decant the solution in beaker label N into another clean beaker. Okay, I'll provide another beaker. If you're not sure how to do either of those, check with me before you do it. All right, siphon out is you just take your another plastic pasture pipette and carefully siphon out what you need. You don't need the salt, you only need the liquid. And then step 24, turn on the hot plate. Make sure the knob is not more than 2 or 3. You don't really need a lot of heat. Okay, dichloromethane is very, very volatile, so you don't need a lot of heat, just a little bit of heat. Set that beaker after you decanted the clean beaker containing the solution N onto the hot plate and just let it heat up, so that say you start with some volume, just wait for half of the volume to disappear. Take it out of the hot plate with tongs, cover it with a paraffin film, set it aside. All right, that's your first. You will not do anything to it today, just leave it aside. All right, to the side. Moving on, step 25 and step 26. Take the beaker containing your solution A and you're going to filter it. I will help you a little bit here. If you get that far, you should be able to get all 26 done today. It's not that long. I have done it very comprehensively, so you see every step of what I have done. All right, so you will filter 25 and 26. You would have to weigh the filter paper in each case before you filter, and then I will give you a little sheet where you can write that information down, and then you will just label it like this with a tape: base, acid, and neutral. You see, we filtered the acid and base, and the neutral is the one that came off the hot plate, and you can see it's dried. Now I have got my samples back from the mixture. Acid, base, and neutral are completely separated. So at the end of step 26, this is what it looks like. This is where you complete the lab. Push these 3 things to the side, allow it to dry, air dry for next week. When you come in, you can weigh and get the % yield. Now the most important thing, at this point you still have to have your goggles on. You cannot take off your goggles because you're done. There's still people doing the lab. You still have to have your goggles. Please do not take off your gloves the whole time, because a lot of these chemicals are not very forgiving, so please be careful. And then push these to the side, and then you will have that filtrate that was sitting in the conical flask. When you filter, there will be a liquid left out that goes in the white container, or actually just leave it, I will take care of it. That's waste that does not go in the sink. So push that aside, push all your glasswares that are dirty to one side, so your station is now empty. Now take a wet paper towel, wipe your station thoroughly, and then with a dry paper towel, so your station looks just like, at least nearly looks like what it was when you came in. Fold your lab coats, put them away, put the goggles where they go, and then you're free to leave. Okay, that's when you complete the lab. You don't stop at 26 and leave. You have to follow the remainder of the steps so that your station is presentable and I don't have to do more work to keep the lab clean. All right. And then I would also highly recommend you that you look at the lab instruction and particularly read the grading criteria. Okay, starting this lab, the grading criteria will be enforced a little bit. The first lab was just basically a minor skill test. This lab onwards, your grading will be determined on the level of finesse you put into the lab. So please do take the time to go through the grading criteria, and that would be it. All right. So please watch the video. I would also provide a copy of this PowerPoint as part of your directions. All right. See you tomorrow. Bye-bye.